It's difficult to predict when Yellowstone will erupt again because we don't know how it erupted in the past. If we knew more about its past eruptions, we could better understand its future behavior. So scientists have been trying to find out more by unearthing ancient eruptions that happened hundreds of thousands of years ago. In this video, I'll tell you how they found these buried eruptions and what they found out from them. When people think of volcanoes, they usually imagine flowing rivers of lava. And while lava is one of the things that can come out of a volcanic eruption, it's not the only thing. Explosive eruptions send ash, rock, and gas into the air, and the further away you are from the volcano, the less dangerous it is. Most of the time, most of the stuff ejected during an eruption doesn't go very far. It falls back down near the volcano, but occasionally some of it travels much farther than you would expect. In the case of Yellowstone, scientists believe that the powerful eruptions that formed the supervolcano were so big that their ash fell over much of North America. And if we can find that ancient ash, we can learn a lot about those eruptions. We know that there have been 3 major eruptions in the Yellowstone supervolcano in the past 2 million years. The oldest one was about 2 million years ago, then another one about 1.3 million years ago, and the most recent one about 640,000 years ago. But before scientists started unearthing ancient eruptions, they didn't know how many eruptions there had been, or if any eruptions had occurred after the 3 big ones. They also didn't know the ages of these events, or how big they were. Scientists used a few different techniques to try to find the answer. One of them was looking for tephra. Tephra are pieces of rock that were blasted out of the volcano during an eruption. If the pieces are less than 2 millimeters across, they're called ash, and tephra can travel really far. Scientists searching for evidence of ancient eruptions look for specific kinds of rocks that can only come from a volcanic eruption. They're called marker units. A marker unit is a layer of rock with a particular composition that tells us something about the magma that was inside the volcano at the time. By dating the marker unit, we know the age of the eruption. And by studying the minerals in it, we can find out more about the magma. For example, scientists found a layer of rhyolite ash in the cliffs of Jackson Lake in Grand Teton National Park. The ash was deposited during one of Yellowstone's major eruptions. By measuring the amount of different isotopes of argon and potassium in the ash, scientists determined that the eruption was about 640,000 years old. But to figure out how big the eruption was, they needed to know how much of that ash layer had been eroded away over the past 640,000 years. They did that by looking at other layers of ash in the area and calculating how much older they were. Once they knew how much erosion had happened over that time, they could estimate how thick the ash layer was when it was first deposited. Based on the thickness of the layer and the size of the volcano, they could calculate the volume of material ejected during the eruption. This tells us that the most recent supereruption had a volcanic explosivity index, or VEI, of 8. That's the second highest rating on the scale, where 8 is reserved for eruptions that eject more than 1,000 cubic kilometers of material. But scientists wanted to know if there had been even bigger eruptions in Yellowstone's past, so they kept searching for ancient ash layers. In 2007, they discovered an ash layer at the bottom of a lake called Lake Tahoe, about 300 kilometers from Yellowstone. But the age of the ash was surprising. At first, scientists thought it was about 1.3 million years old, based on the geological layers above and below it. But then they analyzed the argon-potassium ratio and determined that it was actually 2.1 million years old. And it wasn't from one of the 3 big eruptions. To date, this is the oldest eruption scientists have found evidence for. And because the ash layer is so thin, the eruption must have been much smaller than the others. Scientists think this was a so-called magma-poor eruption. The magma chamber that feeds Yellowstone had mostly emptied out after the previous eruption, so there wasn't much magma left to erupt. Scientists are still analyzing samples from this eruption, but they think the magma chamber started filling up again after this event. Eventually, it was full enough that it erupted in a massive blast about 1.3 million years ago. Scientists think the magma chamber has been refilling ever since. Each time it gets full enough, It erupts, creating the supervolcano we know today. So while it might seem odd to talk about a nearly 2.2 million year long period of geologic time as recent, it's only been in the last 500,000 years or so that Yellowstone has really gotten going. But scientists still aren't sure why the magma chamber refills so completely each time. If they understood that process better, they might be able to make a better estimate of when the next eruption will happen. Meanwhile, they continue to search for more evidence of past eruptions to get a better idea of the whole history of Yellowstone. One way they do that is by drilling holes into the ground. Sometimes they drill into the ground directly. Other times they drill into ice. That's because in the summer of 1985, scientists realized that there was a large reservoir of ice beneath the caldera. They call it the North Fork ice sheet. It's 50 meters thick in some places and covers an area of 580 square kilometers. The ice isn't all in one piece, though. There are a lot of lakes, rivers, and streams underneath it. All that water makes drilling into the ground difficult because the drill bits tend to melt the ice instead of breaking it. But scientists really want to get through the ice sheet to study the lake water beneath it. That's because when ice melts, it filters out the dissolved gases in the water, leaving behind only pure water. And that water can contain chemical evidence of past volcanic activity. The water might also hold ancient DNA. If scientists can find it, that could help them figure out when life returned to the area after a super eruption. So far, scientists have drilled through the ice twice, and both times they hit rock at about 100 meters below the surface. The drilling project was temporarily abandoned until researchers could come up with a new strategy. Finally, in 2016, scientists tried a new method of drilling, and they successfully reached the unfrozen ground beneath the ice sheet. The device they used is called a hot water drill. Instead of using a rotating drill bit to break up the ice, it pumps hot water into the hole. That melts the ice, and a special drill bit breaks it up. The hot water also prevents new ice from forming in the borehole, which keeps the water from refreezing around the drill bit. The device managed to drill 4 kilometers deep into the ground without melting the drill bit. That's about as deep as 1,000 basketball courts. Hot water drilling works so well that scientists are now planning to use it to drill even deeper into the ground. They hope to reach the magma chamber itself, which is about 6 to 10 kilometers below the surface. That won't be easy, though. Magma chambers are hot, and the intense pressure scientists would face at that depth would probably destroy most conventional equipment. But if they can get through, it would be a scientific goldmine. The magma chamber might contain clues about where the magma comes from and how it interacts with the crust. The magma chamber might also contain liquid magma, which scientists could analyze to determine the chemistry of the magma. And it might even contain solid crystals that act like tiny time capsules, recording details of the magma's formation. Hot water drilling may even let scientists explore other features beneath Yellowstone, such as the magma's plumbing system and ancient routes of past eruptions. While drilling into the magma chamber is likely still a few years away, scientists may have to overcome some obstacles along the way. For example, they need to find a way to bring the data from such extreme depths back to the surface. Recording equipment can't just be dropped into a hole and retrieved later. They may need to develop instruments that stay in place for months or even years, and the data they collect will be extremely valuable, helping us understand not just Yellowstone but volcanoes all over the world. Thanks for watching this episode. If you would like to see more videos like this in the future, please subscribe and leave a comment. See you next time.